So I just made a pretty plot while everyone else was doing real work. Uh, so I basically just used Saracen and K3D, which I found out existed because of Griselda's talk. I'll skip to the answer first, but it's just the thing I sent on the Slack. So it's basically a 3D volumetric plot that you can manipulate in real time once it runs. Hello. Sometimes it crashes. Oh, it's okay. Here it is. So you can like eventually zoom in. I promise it's good. Yes, this is one of Ali's flyby simulations. So you can actually like drag it around and have a look in real time. You lose a lot of resolution because otherwise it crashes. So it's good for having a bit of a look to get an idea, but you kind of lose the whole advantage of SPH of having like lots of resolution when you have lots of particles. Well, I'm about to. So the way that you do it is you take the particle data from a phantom dump and you read it to a sarracen data frame, which is just one line basically. You take the particles out and you just interpolate it onto a 3D grid. So that's what I mean by losing resolution. In the dense regions, you have lots of particles, but I'm turning it into a grid code. And then once you have that, it's basically just, there's like a technical detail. You have to convert it to a 32, like float 32, so that it doesn't crash. It's mostly making sure it doesn't crash. And then you just do this plot with a few options, and yeah, this is what you get. So this notebook's on the Slack channel if you're interested in doing this with whatever simulation data you have. It's mostly just fiddling until it doesn't look terrible and doesn't crash. But yeah, that's all. Yes, Rail. Yeah, so when you interpolate it from Saracen, you can tell it what size grid to interpolate it on is one thing, and then also when you plot it, there's this like compression level thing. So I just let Saracen pick the grid size to interpolate it onto because it picks better than I can do, and then I have to turn the compression up till it stopped crashing. So I tried interpolating it onto a bigger grid, but yeah, crashes. So I actually think that you could do a better job because I think that my computer's only giving Jupyter a certain amount of memory, because when I checked how much memory I was using, it wasn't that much. So if you can figure out how to like tell it to let it use more memory, then you can probably run it at high resolution. Like that? Oh yeah, I'm gonna have to. Yeah. Does it just color the points like on the density or? Okay. Yeah, it's a plugin for Jupyter. So it's actually a little bit weird to get working. You have to install a couple extension things. It's this stuff. So I have no idea. That's a very sensible question. Well, presumably it's using some.
graphics card. So one of the things we had a project going with an undergraduate student is like a sort of point cloud rendering, but you make each particle like a fuzzy sphere. And then you get like really like SPH rendering live, so you can do this kind of manipulation. So we had it in the VR headset. It was in the Unity plugin, so it was like different. It's like really simple.
Yeah, it's real. This is really easy. Yeah.
I wonder if like a nice project might be fuzzy sphere. It's basically what we call it, it's like a shader. Do it like a point cloud where each particle is like that. This is a really nice example of the power of Python, but combining like what Andrew presented at the start of the week with what this enables is all the other stuff that's.
Yeah, exactly. It's like you want to do something in Python. It's like, oh, someone already did it. Easy. Oh yeah, that's all.